Hello children, let's begin with a new chapter, that is chapter number 2, Fractions and Decimals of Standard 7. Let us begin with the introductory part followed with some examples. Here let us learn about various types of fractions. The first one is a proper fraction. Here on the screen you can see certain examples, say 2 upon 5, 5 upon 7, 1 upon 19. In all these examples you will find that the numerator part is lesser, smaller than the denominator part. That means it is a part of the denominator. Numerator is a part of the denominator. So a proper fraction is a fraction that represents a part of a whole. So you can see now in the figure that out of whole, some part is colored. Either it is the entire colored or it is only some part that is colored. So 8 upon 8, 3 by 12, 2 by 20, etc. are the examples of proper fractions. Let us see more things. The next one is improper fraction. An improper fraction is a combination of a whole and a proper fraction. So it will have a whole number as well as a proper fraction. We'll see all these things in details now. Here, if you look at the first example, it is 9 by 4. Each figure is divided into 4 parts and in all 9 parts are shaded. 9 upon 4 can be further written as 2 integer 1 by 4. So 2 complete parts shaded and out of the third it is only one part that is shaded. So this is how an improper fraction can be considered to be a whole number and a proper fraction. You can go through the next examples. The next one is a mixed fraction. This is a combination of a whole number and a proper fraction. Basically, we can easily convert an improper fraction into a mixed fraction, and the other way also it is possible that we can change a mixed fraction into an improper. Here, one example is shown. There is a complete pizza and another one, it is just 3/4. So, if I talk about the entire pizza, it is 1 3 by 4 of the pizza. So, the number is written in the form of a whole number and a proper fraction, and it comes up to be a mixed fraction. Next is equivalent fraction. Equivalent fractions have equal values. So if you look at the examples, 2 by 5, 14 by 35 and 10 by 25, they actually mean the same. It is different representation of the same number. Here, if I multiply 2 by 5 with 7 both in the numerator and denominator, I get 14 upon 35. Now, if I multiply the numerator and denominator by 5, I am getting the last fraction, that is 10 upon 25. So, we can say that all the three are equivalent fractions because their value is mathematical value is actually the same. Now, here you can see it in the picture. The first figure is 2 by 2, that is nothing but the complete one shaded. The second one is 4 by 4 because out of all the 4 are colored. That is again the entire thing, that is one complete. So 1 can be either written as 2 by 2 or 4 by 4. Similarly, the others are also shown. Next, we come here with certain examples to solve. Question number 1 of exercise 2.1 is solve the given example. Here you will see that the number 2 is a whole number and 3 by 5 is a fraction. So we are subtracting a fraction from a whole number. In such cases, it is always advisable to convert the whole number into a fraction. It is well possible because 2 can be written as 2 upon 1. So we can do the corresponding changes. The next step is finding out the LCM. Here the LCM of 1 and 5 is 5. Let us make the corresponding changes and try to make the denominators same. The first fraction is to be multiplied by 5 in both numerator and denominator, and the second one is to be multiplied by 1 so that we get the same denominators. One thing that we have to understand here is the first fraction, that is 2 by 1, has been now written as 10 by 5. These two are equivalent fractions. Their meaning is same. Mathematically, they are equal. So basically, we have not changed the example. We have just changed the form of the example. Now we can easily solve it out. 10 minus 3 to be solved and the denominator to be written once. So the final answer is 7 by 5. Let's come up with more examples. Here again we are having one whole number, another is a fraction, but we are adding it. We are going to use the same method. First we are going to write 4 as 4 upon 1. Now we'll find out the LCM. Whenever we add or subtract fractions, we have to use the LCM method. So here the LCM is 8. So our aim is to make both the denominators as 8. The second denominator is already 8. So we will do the corresponding changes in the first denominator. So this is what we are going to do. It is just multiplying the first fraction by 8 in the numerator and denominator. Now we have the example converted into 32 by 8 plus 7 by 8 with the same denominators. Now we'll solve and we'll get the final answer. Now the final answer is an improper fraction. If you wish, you can convert it into mixed fraction also. Another example to go. Here we have addition of two fractions. Let us begin with the LCM. Here the LCM is 35. So we are going to make the denominators 35. Do the corresponding multiplications. Here we'll need to multiply the first fraction by 7, both in the numerator and denominator, and the second fraction by 5, both in the numerator and denominator. This is how we have changed the denominators to 35, which was our LCM. Now we'll quickly add the numerator and we'll get the answer. We have to check the answer once. We should always have it in the lowest form. But in this case, 31 and 35 itself, they are in the lowest term. So we'll keep it as it is. One more example. We are subtracting fractions. Obviously, we are going to use the same method, that is the LCM method. Here the LCM is 165. So we are going to do the corresponding changes so that the denominators become 165. We'll need to multiply the first fraction by 15 and the second by 11 in both numerator and denominator. After that, we'll subtract the numerator and we'll get the final answer. That's all for now. We'll come up with more examples in the coming videos. Thank you for now.